Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over a problem involving molar volume and stoichiometry. Okay, so I'm going to go over a couple of example problems, and this is the first example problem. So one of the things we need to remind ourselves of is what is molar volume? The molar volume, basically, as the term says, is that it's the volume of 1 mole of a gas. And so, under special conditions called standard temperature and pressure, or STP, the molar volume is 22.4 liters. So, the mole of any gas is going to be equal to 22.4 liters at STP, standard temperature and pressure. So we need to remember that. Because if we remember that, and if we're given a problem where we recognize that we are in STP, they might say that we're in STP, or they might just give us the conditions of STP. And if we recognize that, we can make our problem a little bit simpler. So let's remind ourselves what standard temperature and pressure is. So standard temperature is going to be 0 degrees Celsius, and standard pressure is going to be 1 atmosphere. So let's look at our problem. So they give us an equation to form water from hydrogen and oxygen gas. So we're forming water vapor, which is in the gaseous phase, from gaseous oxygen and hydrogen. So the only thing we have here is a question, and as I said, the question always tells you, or not always, but 99% of the time, it's going to tell you where to begin and where to end. So the beginning of the question tells you where to end. How many grams of water? There you go. That's the ending. So we need to find grams of water. So where are we going to need to start? Well, the only other piece of information they give us is 1.24 liters of hydrogen gas at STP. So we're going to have to start with 1.24 liters of hydrogen gas. And so they give me liters, and they give me STP. So I can use this as a conversion factor. So if you're under STP, you can always use the molar volume as a conversion factor between moles and liters. So I'm going to start with 1.24 liters of H2 gas over 1. I'm at STP. So if I didn't recognize I was at STP, then I would use the ideal gas law, plug in the values for this and the volume and find moles. So that would be an extra step. And actually an extra 2 steps, because I would have to convert the temperature to Kelvin, which in this case is pretty simple because you're always adding 273. So in this case, it would be easily 273 Kelvin, or 273.15 Kelvin. So it's a little bit simpler if you recognize that you have molar volume at STP. So this is what I'm referring to as recognizing that you are under STP conditions. So for instance, if they don't tell you it's at STP, but they give you 1 atmospheric pressure and 0 degrees Celsius, you can recognize that that is under STP and solve accordingly. So since I recognize it's at STP, they tell me I'm going to use the molar mass as a conversion factor, or molar volume as a conversion factor. So that's going to be 22.4 liters of H2 gas and 1 mole of H2 gas on the top. So liters cancels out. Now I have moles. I want to go from moles of hydrogen to moles of water. I can use the balanced equation, the mole ratio, hence stoichiometry. So for hydrogen, it's 2 moles of hydrogen for every 2 moles of water. So it's 2 to 2. So 2 moles of H2 gas to 2 moles H2O gas. Don't need to really put the gas in there. So moles of hydrogen cancel out. Now I have moles of H2O, but it's asking for grams, so I'm not done yet. So I have to do another conversion factor. So I'm going to go from moles of water to grams of water. So I'm going to use the molar mass to convert. So 1 mole of water on the bottom. And water, that's 2 plus 16, it's going to be about 18 grams of water on the top. Moles of water cancels out. I have grams of water. I am done. So the only thing I need to do now is calculate the answer. So I'm going to take 1.24 multiplied by 2 multiplied by 18 divided by 22.4 divided by 2 equals, and I get 0.996428, blah, blah, blah. So that's going to be grams of water. Okay, now I have to figure out the number of significant figures. So this here is a measure, so 22.4, that's 3. This is exact, that's just a ratio of numbers. This is again, I estimated, so this will like have several decimal places after it, so this is like 4. And so this is 3, the least number is 3, so I would cut it off after the 6, 1, 2, 3. So I cut it off here, and that would be the number. Notice I'm not rounding because the number that comes after it is less than 5. So that's why I'm keeping it at a 6. And so that's how you can use the molar volume under STP conditions to help you convert from volume of gas to moles directly without using the ideal gas law. But if you don't recognize that it's under STP, or if you forget, you could always use the ideal gas laws before. It's just, a few extra steps, but it'll get you the same answer. But on a test situation, you want to find shortcuts, so that'll save you time. I hope this video was helpful. If you like the video, share it with your friends, hit the like button, hit the subscribe button down there, and also make a comment down in the comment section. Tell me what you think of the video. Let me know if there's anything else you want me to go over. Thanks for joining me, and I'll see you next time.